Hello friends, today we are going to discuss about the Andrews experiment on CO2. The apparatus used by Andrews in 1869 to study the isothermals of carbon dioxide at different temperatures. The construction of this experiment, the apparatus consists of two similar glass tubes A and B having thin capillary tubes at the top and bulbs in the middle. Initially, in the tube A, the pure air is passed for a long time and then sealed at both the ends. Similarly, in the tube B, CO2 is passed for a long time, nearly 24 hours, and then both the ends are sealed. The lower ends of these tubes are immersed in mercury. A small pellet of mercury is drawn in both the tubes by alternately heating and cooling the tubes. Both the tubes are fixed in H-shaped copper vessel having steel stoppers S and S dash. The vessel is fitted with water by screwing in the plunger, means the pump piston. The water is compressed by and the pressure is transmitted to the enclosed gases. The pressures of the order of 400 atmospheres can thus be applied. So, and the apparatus, since the pressures of air in A and CO2 in B are the same from the volume of air in A, the pressure of CO2 can be calculated assuming air to obey Boyle's law. The volume of CO2 is read from the tube B as it is calibrated to read the volume directly. Both the tubes are surrounded by water baths, which is shown in figure. Air is kept at constant temperature. The temperature of CO2 could be maintained at the desired temperature between 0 to 100 degrees Celsius. In Andrews' actual experiments, isothermals were drawn at temperatures 13.1, 21.5, 31.1, 32.5, 35.5 and 48.1 degrees Celsius. From the isotherms of CO2 at various temperatures, following conclusions can be drawn. At is 31.1 degrees Celsius. The portion AB, this is portion AB, represents the gaseous states of CO2 up to the point B. It obeys Boyle's law. From B to C, volume decreases suddenly, means enormous decrease with slight increase in pressure. The portion BC represents the means of CO2 from gaseous to liquid state. At C, the gases has been liquefied completely. The portion CD, this portion CD represents the liquid state of CO2. This is about the for the 13.1 degrees Celsius portion, and at 21.5 degrees Celsius the curve is similar. The horizontal portion BC has decreased further to FG, At 31.1 degree Celsius, the horizontal portion is just vanished. This is called critical isothermals for CO2. Above the temperature 30.5 and 48.1 degree Celsius, the horizontal portion does not appear to all, and the gas obeys Boyle's law from one end to the other. These isothermals are similar to the isothermals for CO2. Thus, for CO2, the critical isothermals divides into two regions. Above the critical isothermal, the CO2 gas cannot be liquefied, howsoever large the applied pressure may be. Below the critical isothermal, CO2 gas can be liquefied by the application of pressure alone. The dotted line, the dotted curve, this dotted curve shows the whose highest point is P is called as a critical point, and the temperature 31.1 degree Celsius of the isothermal is called critical temperature. Was critical temperature Tc means it is the defined as the maximum temperature at which a gas can be liquefied by the increase of pressure alone. Above this temperature, the gas cannot be liquefied, howsoever large the applied pressure may be. Then this is the Pc, means critical pressure. The pressure necessary to liquefy a gas at critical temperature is called critical pressure. Critical volume Vc, it is the volume in which unit mass of gas occupies at the critical temperature and critical pressure. These three quantities Tc, Pc and Vc are called critical constants of gas. Means critical point means it is that point on the isothermal for the critical temperature at which the change of state from the gas state to the liquid state takes place under constant values of Pc and Vc. So this is the construction of the Andrews experiment. This is S-shaped copper vessel. These A and B are the two glass tubes. The upper portion is in the form of the capillary in the glass tube A. Upper portion is filled with air, and in the tube B it is CO2. These uh, they at the end of these tubes uh, there are two stoppers S and S dash, and the shape of this vessel is H-shaped copper vessel. This is the isothermals of CO2 and air. This is the critical point P, and this is critical pressure Pc. This is critical temperature Tc. These are the isothermal for 13.1 degree Celsius, 21.5 degree Celsius, 31.5, 30.1, 31.1 degree Celsius, 32.5 degree Celsius, 30.5.5 degree Celsius, 48.1 degree Celsius. So this is the portion of AB. Then this is about the liquid region. This is the about the liquid vapor region, and this is the gas state region. And at a particular temperature 31.1 is the critical temperature here, and this portion GF is similar to the BC, that is which is decreases with increase in volume. So these this is the isothermals of carbon dioxide CO2 and air, and this is the construction of the Andrews experiment on CO2. The A and B are the two capillary tubes. It contains air and B contains the CO2. With the screwing arrangement of these stoppers S and S dash, the pressure is formed, and the which is calibrated on the tube B. So this is about the Andrews experiment on CO2. Thank you very much.